Let's look at cost behavior from a different standpoint. Instead of looking at the computations or a table, let's look at what these represent in terms of a graph. And so we're going to look at the total cost and average total cost, fixed cost, average fixed cost, variable cost, average variable cost, and then the marginal cost. So for total cost and average total cost, we're always going to have dollars on the vertical axis and quantities on the horizontal axis. And total cost will always start with an intercept above zero. So on the dollar axis, on the vertical axis for total cost, it starts at an amount greater than zero because that's going to be equal to the fixed cost. If they don't produce anything, they still have some total cost because they've got fixed costs. And then the curve slopes upward because of the increasing amounts of variable cost as they increase the level of output. And as we saw in the table computations, average total cost starts high, hits a minimum at the efficient scale, and then starts to increase again because average total cost is a combination of the average fixed and the average variable costs. And so that Q star there is the efficient quantity for the firm, and it represents operations where the cost per unit, right, the average total cost, which is the cost of a typical unit, will be minimized. When we look at fixed costs, the costs behave differently. Fixed costs in total are a horizontal line because no matter how many units we produce, regardless of where we are on the Q or horizontal axis, we have a certain amount of fixed costs, and that can't change in the short run. But on an average basis, the average fixed cost is going to be downward sloping and sort of always get closer and closer and closer to the horizontal axis. So the average fixed cost gets smaller and smaller and smaller as the quantities increase. For variable costs, the picture is very different. In total, the variable cost starts at zero because if you don't produce anything, you don't have any variable costs. There are no ingredient costs. There are no costs for labor. But then the more units you produce, the more you have variable cost. And so it's going to increase and go upward, and it's going to do that at an increasing angle because the more you try to increase your output for a given amount of factory space, the more you're going to have to speed up your machines, the more crowding you're going to have, the more laborers you're going to have to pay for overtime, and so the cost increases at an increasing rate. That variable cost curve gets steeper and steeper. Average variable cost sometimes falls initially and then it must slope upward, so it's usually somewhat U-shaped, though it doesn't have to be. It can slope only upward, but usually it's sort of parallel to the average total cost curve and usually lies just below the average total cost curve. And then the marginal cost curve usually looks somewhat like a Nike swoosh because marginal cost can fall at first, but it also must rise and so will increase at an increasing rate. And so how are all of these graphs related? If we draw the average total cost curve, we're going to see that it's U-shaped and it's going to have a minimum. We're going to see the average fixed cost curve slopes downward, getting closer and closer to the x-axis. The average variable cost is sort of U-shaped as well and lies below the average total cost curve. And then the marginal cost curve will intersect the average total cost at that ATC minimum, at the Q star. And so Q star is going to be determined by the average total cost. And mathematically, the marginal cost curve, the orange Nike swoosh there, always intersects the average total cost at its minimum. And there's a separate screencast that discusses why that has to be the case.